Given the fact that the microvibe was built on a very low budget using off-the-shelf stereo components, we've created one of the leading high-frequency seismic sources. My name is Kevin Brewer. I'm a geophysical technologist, and in my group I'm responsible for building, designing, and maintaining the various pieces of equipment that we use for our survey work. So one of my first jobs at the Geological Survey was to build and come up with the microvibe. The microvibe is essentially made up of high-end stereo components. We use two high-power car audio amplifiers to drive essentially subwoofers into the ground. It rides on top of snowshoe plates that are used on snow plows that you'll see on the city, all held together on a concrete block that we had to pour in the basement of the Geological Survey. So today we're in Embrun, a small town east of Ottawa, doing a seismic survey for groundwater studies to get a better idea of the subsurface. So the subsurface is everything from ground surface down to bedrock, which is typically in this area composed of sand, gravel, and glacial tills that store and transmit much of our groundwater. So the microvibe generates a frequency sweep which travels down into the ground and reflects back up to our receiver array, which we call the land streamer. The current land streamer we have right now has 48 different sleds, each sled having 3 geophones, 2 in a horizontal direction and 1 in a vertical. And that allows us to create a detailed image of the ground, very similar to an ultrasound. So the survey we're doing today is for groundwater studies. We're studying the subsurface to get an idea of where you would find a good supply of groundwater and how deep that groundwater is. We can also use the microvibe for geotechnical purposes, such as finding old ancient landslides or the signs of disturbed ground. When building infrastructure, it's handy to know if an area has had landslides in the past or has potential for landslides in the future. The high frequency and high resolution of the seismic survey gives us that information. In the Near Surface Geophysics group, one of our core mandates is to come up with new techniques and pieces of equipment for seismic surveying and other geophysical surveys. The microvibe being one of our most successful developments in the last few years. One of the great parts of my work here at the Geological Survey is it's always changing. We're always working on new ideas and new theories, building up new pieces of equipment from completely random parts. And it's always thinking outside of the box and coming up with innovative ways to do things that haven't been done before.
If you like this video, let us know with a thumbs up. Click on the logo below to subscribe to the Simply Science channel and click the bell icon to be notified when we upload new videos.